So for my final project for Introduction to Fluid Dynamics, I will be talking about the Marangoni convection on bubble surfaces. So if you look at a soap bubble surface, you see these mesmerizing colorful swirls that are moving around on the surface of the soap bubble. And I've always been really curious to understand why these are formed and how they move around like that. And when I was doing my research, what I came to understand is that this is formed by a phenomenon called the Marangoni convection. And this phenomenon is induced by the surface tension gradient along the interface between two fluids. So in the case of a soap bubble, these two fluids are the liquid bubble film and the gas inside the bubble. So when I'm talking about Marangoni convection, I said that there has to be a surface tension gradient. And what this means is that the surface tension is a tendency for liquids to shrink themselves and occupy the smallest possible surface area. And if we look at the liquid-air interface of the bubble, the surface tension is caused by the greater attraction the water molecules have with each other than they have with the air molecules. And another important topic that we need to talk about in terms of Marangoni convection is the surfactant. So surfactants are actually compounds that lower the surface tension between a liquid and a gas, or it could be between liquid-liquid or liquid-solid, but in the case of the soap bubble, what we're interested in is the liquid-gas interface. So these surfactants are actually compounds that are amphiphilic molecules with a hydrophobic tail and a hydrophilic head. So they align themselves so that the tail is in the air region and the head is in the water region. And when there is a surface tension gradient, these surfactants are tugged toward the region of higher surface tension so that they can go in there and lower the surface tension. So how can we create a surface tension gradient? A surface tension gradient can be created by introducing a change in the solute or the surfactant concentration, and this type is not known as the solute Marangoni effect, or it could be created by introducing a thermal gradient, and this type is known as the temperature Marangoni effect or the thermal Marangoni effect. In the case of the soap bubble, what we're interested in is the solid Marangoni effect, and I demonstrate this in an experiment in the following video. So in this video, the milk and the food coloring has the higher surface tension, and when we introduce dish soap, it instantly causes a Marangoni convection, as we can see here. And that's because the surfactants are traveling towards the higher surface tension. I did a similar experiment using water and pepper flakes, as we can see now. And here the water has a higher surface tension, and the pepper flakes will act as a tracer so that we can see what happens when we introduce a soap solution, which will have a higher concentration of surfactants. And we instantly see a Marangoni convection because there's a surface tension gradient that is created here. I also learned that studying the Marangoni convection in these soap bubble surfaces have actually helped scientists solve real-life problems. A group of scientists in Stanford University in 2016 found a cure for alleviating dry eyes because the tear film of our eye actually works as a natural surfactant. They also made the amazing discovery of finding replacement lung surfactants to prevent collapsed lungs in newborns because the tiny air sacs contained within our lungs also act as a natural surfactant layer. Right now, they're also looking into separating crude oil from water. So what we wanted to learn was how these swirls are formed and why they move around on the soap bubble interface. And what we learned was that this is caused by the Marangoni convection, which is initiated when there is a surface tension gradient. And this surface tension gradient is formed when there's a higher concentration of surfactants, which is introduced by the soap in the soap bubble. And that's why we see these mesmerizing swirls and the different colors that are formed on the soap bubble. Thank you, and I hope you learned a little something about what makes soap bubbles so attractive.